This video is to showcase the work that we have done for industrial controls. So this is a website which would tell our classifications as industrial purpose and residential purpose. So one of our biggest need of the hour for most of the industrial requirements are that you want to monitor your machineries, your plants all the time and see how your machineries are really behaving in the real time or when they are in the production pipeline. Okay. So given that as a requirement, we build a platform which would continuously monitor and then send the readings of the system that's operating. For example, this machine, this motor that's running is continuously being monitored by this device here, and then as it gathers the data, right, it will transport the data over the internet to our platform here that comes down to here. So you could see here, when I go to the other tab, you could see the actual data of this device that's operating along with the machine here being transported to my platform, and the data are real time. So we are monitoring hourly right now, and it's been going through enough of testing to validate if the system, if the device is really working fine. So far we have around 16 input parameters to monitor. So those input parameters data is what you're seeing on the graph right now. So coming down to this particular device that you're looking at it, right? So it has got a potential to measure 16 analog inputs. Out of those 16 analog inputs, so I was saying that this particular device has got 16 analog inputs and it has got a potential to control 4 different devices. You can see here through the 4 different relays that it has got. Fine. And it's got 16 analog inputs on either side, 8 on this side and 8 on the other side. So right now the motor is being controlled using the 8 analog inputs that we have. So those are the 8 analog inputs on the other side, and we have a power supply. We need to provide a power supply for it, which is on this side, probably here. So there's an input that we provide for this device, and that device gets activated through the input, and it's got a chip, Internet of Things chip, which would start to measure the analog inputs such as current, voltage, vibrations. Then it can also measure pressure, temperatures, whatever you can think of. There are so many sensors that we support, and all the sensors are listed on our website. So you could go to them and then you can ask for that support. So once this box is assembled on your side, right, the potential of this box is to transmit the data that's gathering from the sensors. Right now I have 3 current sensors and a voltage sensor, and then a vibration sensor being installed at the back of the motor. So it's passing all the data to this particular device. The analog data that's being gathered by this device, as I said, is being transferred to my platform here. And the data that you would see here on the platform is in the form of waveforms or in the form of table data at the bottom here. And then you can have many features which will let you to plot by weekly, hourly, daily, and you'll get to know your statistics, how your system is really behaving on a specific given time or a period of time. Okay, so that's one part of the system that you are seeing right now. We have many other interesting features. Once I would log in, so this is what you would see. Basically, a person would come down to our website, and probably once he comes down to our website, you would read the kind of sensors we support. The list of sensors we are that we support are being listed down here. So some of these are the sensors that are more general, common in nature, and they would be supported by our device. And once you have placed an order, one of our technician would come down to your site, install the box along with the sensors to the particular machine that you want to control. Once it's been installed, the data will be enabled for you on your platform, on our platform, which you can log in and then try to access. Right now, I'm showing a simple access that one of our users can have it. And then you can see that any given user could have more than one unit. We are calling this different customers. So we can call it as type 1, type 2 customers. And then this is a customer you would select. And then, sorry, this has got no data. Right? So there's this one. This is what I have to go for. Yeah, this is the one. So the device that you are currently seeing is this one. So given a plant, right, there can be many devices, not a single device, because you would have many machineries, not a single machinery. So you need to measure all your machineries, how is it behaving. So at this point of time, I'm using only one machinery to give a demo or showcase our potential, but you can have many of these. Many of these can be installed in parallel and each one can be controlled. Some of the other interesting features that you would really see is when I say the inputs, right, you can have your inputs named to according to your machinery. So we have 16 inputs, I said, and they can be defined of any type of measurement of units. So some of them will be called as voltage, amps, temperature, whatever you want to call, fine. And then also we have few other features which are very important. The other very important feature is called as device formulas. I said that we have 4 analog outputs that you are seeing here. 1, 2, 3, 4. The output of these 4 analog inputs, digital inputs, outputs from the platform would be controlled by these formulas. So I'm saying that if A0 is less than 1 amps, right, then you control this particular device or output to a higher state. So it will continuously measure the A0 analog input, and whenever it's lesser than 1, it would probably turn on the output bit of D0 or that particular relay to a higher value, which will turn on or turn off the state of the relay, which in turn would control your machine or your device, fine. So similarly, you can define any kind of formula that you have based on the 16 analog inputs with different combinations and control your machine. Okay, so that's what we try to do here. Now, a specific reading which is matching with this particular formula cannot be termed as an immediate shutdown. So what we also let the user to define is the number of samples it really needs to match with the formula. So let's assume right now we put analog A0 of having less than 1, you turn on the first relay, right? So when we have that formula defined and a sample of 4, you need to have a continuous 4 readings wherein analog input is less than 1 for 4 times. Only then that first relay will be activated so that your system is shut down. Okay, so we don't want to turn on immediately. So we can also change the sample size to 1 to whatever you want as per your requirement. There's no constraint for it. So that's one thing. Another thing is I showed about the formula, right? Let me go down to controls now. Controls is another very important and a very interesting feature. Using this, you can turn on, turn off a motor. So we have this potential right now, and I'm turning off a motor, which is right now it's going to ask, you want to change the state of it? I'll say yes. You can observe the state of this motor. It's turned off. It's off now. So I'll go back, I'll turn it on. It's got a delay of few seconds. We don't want to take actions immediately. So we are causing an intentional delay whenever there's an action taken, because these are machineries and you cannot let the user to take arbitrary actions every now and then. So we have turned it off. Now it's in off state, you can see it. The relay is in off state. I'll turn it on now. It'll ask for a confirmation. I would say yes. So give it some seconds for the action to take place. You can see it turned on. Fine. So basically the device got the control from the platform. It controlled the relay, one of these relays, letting the motor to turn on. So you have the potential there to turn on, turn off. Another important feature that you would see is an auto control. In case of auto, we are measuring the analog inputs from the device, which is this, constantly at specific intervals. Now using that, whenever you have a situation, right, wherein the situation, the analog inputs match for 4 times or based on your sample size, and with the digital output or the relay output being high or low, this is the 2 options that system is configured to take. So you can configure it to take an action of never shut down, even though the relay condition has been met by the formula for 4 times or how much of a sample times that you configured. Or you can have another option to say that have your operator to first confirm that the motor can continue operating after shutdown. This is a very important industrial feature. Why? Because an operator should be given an opportunity to check the motor or check the machinery, why it went down, take an appropriate fix that he has to do for it, then come back to the system, confirm that he has really applied the fix, and then move further down. Okay, so now we have defined a formula which is less than 1. So you would see a current reading on the system there. I'll just go down close by. So the current reading. The current reading of it is 2.3, 2.2, which is balanced. From here, the next interesting part of the system is to see how the real action is handled by the platform, which would be our next clipping. But I think we have seen so far how the platform is built, what are the different features of the platform, what services it can provide for you. I hope it has caught your interest. So let's look for the next clipping for more action. Thanks for listening to me.